Hi guys, welcome to your Unit 3 Lesson 6 notes on probability and odds. By the end of the day, you will be able to find the probability and odds of a simple event. But before we do, let's play around. You go ahead and find a 6-sided die and let's do an experiment. With your 6-sided die, roll it 20 times. And each time you get, like a 3, mark it down, or if you get a 5, you get another 5, you get a 4, you get a 1, you get a 3, you get a 2, right? So mark those all down each time you get one, and roll that until you have 20 trials. So roll the die 20 times and mark down what you have, and then hopefully they will all add up to 20. Pause this video, mark down what you get, and then we'll go on. Okay, you should have rolled your die 20 times. When I did this, I got 1 4 times. I got 2 2 times. I got 3 3 times. I got 4 1 time. I got 5 7 times. And I rolled a 6 3 times for a total of 20 rolls. Next, we're going to calculate what's called the experimental probability of choosing each number. To find experimental probability, you're going to write how many times it happened over the total number, the total rolls. Now here my total rolls is 20. So that will always be over 20. Except I need to find the percent. So I'm going to write them as a fraction first and then find the percent. So my 1, I rolled 4 out of 20 times. 2 was 2 out of 20. 3, I rolled 3 out of 20 times. 4, I rolled 1 time out of 20 times. I rolled a 5 7 times out of 20 times total. And I rolled a 6 3 times out of 20 times total. Now I need to calculate what percent that is. 4 over 20 will give me 20%. 2 over 20 gives me 10%. 3 over 20 gives me 15%. 1 over 20 gives me 5%. 7 over 20 gives me 35%. And for my 6th time, 3 out of 20 gives me 15%. Now if I found all my percents right, they should add up to 100%. Let's check. 20 plus 10 is 30, plus 15 is 45, plus 5 is 50, plus 35 is 85, plus 15 is in fact 100%. Sweet, we must have done something right. Now we need to calculate the theoretical probability of choosing each number. That's what we would expect to happen. So theoretically, it's how many times it can happen over the total. Well, there are how many total ways it can happen? There are a total of 6 ways it could happen, right? 6 total events. 1, 2, 3, 4, 5, 6, and there's only one way to roll a 1. That's 1 out of rolling a 1, 2, 3, 4, 5, or 6. 2, there's only one way to roll a 2. Out of 6, there's only one way out of 6, one way out of 6, one way out of 6, and one way out of 6. They all have the same probability of being rolled, 1/6. But again, it said let's put that as a percent. So okie dokie, we can do that. That's 1.666 or 0.1666. We're just going to call it 17%. Because it's actually 16.6666%, but we'll just round to the nearest percent. So they all have a 17% probability of happening. Cool, they're even. Now these are all our experimental probabilities. So I know this adds up to a little bit more than 100, right? That's 60 plus 42. It adds up to 102% because we rounded up each time, but that's close enough. Okay, so experimental probability with theoretical. How similar are they? Well, remember that the experimental probability is what happened in the experiment, what actually happened. The theoretical probability, on the other hand, was what we expect to happen. So up here, we're expecting to roll each of these 17% of the time. And with my 3s, we rolled that just about what we would expect, right? Same thing with 6. 15% is close to 17%. Awesome. But check it out. This 5, that was way more than normal. And this 5%, that's way less than normal. Yikes. And then the 20 and the 10, they're close. Okay, cool. So that's so fun. So notice that your experimental and your theoretical probability, they don't always match. And that's okay. They don't match. But they should be close. Okay. So by the end of the day, you'll be able to find a probability. Today we just found experimental and theoretical probability. You'll also be able to find the odds of an event. So let's look at this as an example. When you roll a pair of dice, here are your options. For your first roll, you can roll, on your one die, you can roll 1 through 6. On this other die, you can roll a 1 through 6 as well. So how many possible outcomes are there? Well, if we count them all up, there are 36 possible outcomes. And how many of them are rolling doubles? Well, rolling a 1 and then a 1, that's doubles. Rolling a 2 and then a 2, that's doubles, 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 doubles. So 6 of them. 6 of them are rolling doubles. So the probability of an event is the number of favorable outcomes over the possible outcomes. What this means is how many successes you have, how many ways you want it to happen. So basically what you want over your total. So if we looked at the probability of rolling doubles, how many ways can we roll doubles? We can roll them 6 ways. So it'd be 6 over, and then how many total are there? There's 36 possible ways to roll dice. And this actually reduces to 1/6. I promise that that probability is not always equal to 1/6. But it just happened to be in our examples so far. So you'll notice that 1/6, that's a fraction. It's less than 1. It's approximately equal to 17%, or, it's actually 0.1666666 repeating. So it's approximately equal to 17%. All probability will look like this. It'll either be in a fraction, in a decimal, or as a percent. So the probability that an event can happen will always be between 0 and 1. Inclusive means it can equal 0. It can equal 1. That's what inclusive means. It includes 0 and 1. Okay. If you have a probability of 0, that means the event is impossible. It can't happen. However, if you have probability, so impossible, 0% chance of it happening. If you have a probability of 1, that means that the event is certain. It has to happen. It is for sure. And the closer the probability is to 1, the more likely it is to happen. So here we go. We've got a population distribution shown in a chart. If a person is chosen at random, what's the probability that the person is 65 or over? So remember that probability is favorable over total. So the probability of an event is equal to, I ran out of room. I'm just going to start over, write it up here. So probability of an event is equal to favorable, what we want, por favor, over your total. So we need to count up how many options are there of people, 56, or by 50, this should say 65, of people 65 or over? Well, 65 and over, that's just 4. So there are 4 people ages 65 and over. Except, read the chart, millions. 4 million. Ta-da. Now, how many were surveyed in total? Oof, let's do a running total. 3 plus 6 is 9, plus 3 is 12, plus 5 is 17, plus 5 is 22, plus 4 is 26, plus 2 is 28, plus 4 is 32. So 32 million were surveyed in total. And now we need to calculate the probability. So calculating the probability, we want to find the favorable over the total. So how many ways it can happen, what we want, which was 4 million, over the total, which was 32 million. And so when we do that, that works out to 1/8. It reduces down to 1/8, which is equal to 0.125. And guess what, you guys? I will accept any of these as an answer, but my favorite is as a percent. So 12.5%. 12.5% of the population is 65 or over. So that's probability. We already talked about what we expect to happen, what should occur. We call that theoretical, what happens in theory. And then what actually does occur, what you actually ended up rolling, that's experimental probability. That's what would happen in an experiment. So this is actually what my brother does, fun fact. And also, this would make an excellent, great quiz question right here. What is the difference between these two? So mark that, study that. You want to remember that. Be able to explain in your own words the difference between them. Okay. So here we've got a quality control inspector for office supplies checking a sample of 250 pens and found that 14 of them were defective. Oh no. Find the probability of finding a defective pen. Well, again, to find probability, you want to find what you want over the total. Not that we want to find a defective pen, but that's what we're looking for. So 14 out of a total of 250 pens were defective, and 14 out of 250 reduces to 7 over 125. Whatever that comes out to be. There, that's our probability. Cool. Cool. All right. Our last concept of the day are the odds. Like, what are the odds, guys? Well, the odds of an event occurring. It's a ratio of not favorable to total, but favorable to unfavorable. So if you have a bag of, oh, did you hear that? A bag. If you have a bag of 6 red marbles, 3 blue marbles, and 1 yellow marble, find the odds of choosing a red marble. Well, we have 6 red marbles in total. So that's what we're looking at. But we have 3 blue marbles plus 1, oh, that's hard to see, sorry. Plus 1 yellow marble. So the unfavorable outcomes is actually 4. So the odds here are 6 to 4. You have 6 to 4 odds of choosing a red marble. This is different from probability. This would be another great quiz question. The probability, on the other hand, the probability that I spell this word wrong is 0. Probability. Man, guys, that was a struggle. The probability of choosing a 6 is going to be your favorable over your total, which is 6 over 10. So these express the same idea, but this one is odds up here, and this is probability. So while they deal with the same kinds of things, they are different measurements. All right, cool. Well, there you go. Probability is what you want over the total. Odds is what you want over what you don't want. And then theoretical, what should occur. Experimental, what actually does occur. And then the probability that you have fun on your homework is, of course, 100%. Have a great time, guys.